Hello everyone, good morning to you all. So today I welcome all of you to the video on the chapter chemical bonding. We have started the chapter chemical bonding. We have seen how to write Levy's dot structure for a given molecule, right? And then we discussed regarding bond parameters, bond length, bond order and so on we discussed. Thereafter we discussed regarding Fazan's rule. Fazan's rule and how it should be applied for molecules and what are the criteria to be followed for the Fazan's rule, all those things we discussed. After having done all those things, today we will have a discussion on VS-EPR theory. So for the introduction part also I have covered, and still if you consider particularly VS-EPR theory, we will be solving certain examples. ಯಾವಾಗ ನಾವು ಎಕ್ಸಾಂಪಲ್ಸ್ ಅನ್ನು ತಗೊಂಡು ವಿ ಎಸ್ ಇ ಪಿ ಆರ್ ಥಿಯರಿ ಪಾಸ್ಟುಲೇಟ್ಸ್ ಅನ್ನು ಅಪ್ಲೈ ಮಾಡ್ತಾ ಹೋಗ್ತೀವಲ್ಲ, ವಿ ಎಸ್ ಇ ಪಿ ಆರ್ ಥಿಯರಿ is going to be very clear for us. So that was the main reason I have made here. I'm making this video for you all. So now very first I would like to tell you what exactly the meaning of VS-EPR theory. VS-EPR theory stands for, let us expand it first, that is Valence Shell, Electron, Repulsion theory. Valence Shell, Electron, Repulsion theory. Now one by one let us understand regarding these terminologies. Valence shell, we all know this one. If you consider any atom, it will be having particular electrons in it, and we have seen how to write the electronic configuration, right? So after doing that one, we also see how many electrons are going to be left at the last shell. That last shell of an atom itself is referred as valence shell. For your more knowledge and for the clear explanation, let me consider one example. What example I should consider here? I should consider sodium. It is not necessary that we have to consider only sodium. Any atom we can consider. I am telling you regarding how to take the valence electrons. Okay. So when you consider sodium, we all know atomic number is 11. Right. Let us put the electrons in a orbital format. Okay. So in the inner shell, it is said to be S subshell. It is filled with 2 electrons. Then the second shell, it is said to be K. Now we are filling electrons in L. Right. 4 plus 4, 8 electrons. 2 plus 8, 10 electrons are covered. Now let me fill 2 more electrons. I'm sorry, it is only 1 electron because atomic number 11. So 2 electrons in an inner shell, 8 electrons at the second shell, and the last electron will be left in the last shell. Now this last shell which has obtained here is said to be valence shell. What we call it as? We call it as valence shell. Now for VS-EPR theory, we supposed to consider this valence electron. Valence shell electrons are mainly participating in a bond formation. Fine. So that is called by valence shell electron pair repulsion. Now we came to know valence shell electron. Up to here it is very clear. Now they are specifically mentioning the term repulsion. Whenever we have electrons, definitely they are negatively charged. When they come in contact with another atom, there will be definitely repulsion between 2 atoms. This is one atom. Similarly, if you consider any other atom, that will also have certain electrons in it. Due to presence of those electrons with a negative charge as well as negative charge of these atom, together they repel. Fine. Even though these valence electrons, they are repelling in such a manner that, but still certain force of attraction will be overcoming this repulsion. Then only we are going to see the bond formation. Okay. Now let us understand the postulates for valence shell repulsion theory. Valence shell electron repulsion theory. Firstly, foremost, we have understood regarding the expanded form of VSEPR. Now, one by one, in detail, let us learn regarding the postulates. Students, do remember the postulates of valence shell electron, or generally I can call it as Vesper theory or VSEPR theory. Anything, whatever you want to pronounce, you can. So this Vesper's theory postulates what have been given here are going to be asked for 3 marks. This theory is important. Postulates can be asked for 3 marks. Many a times they have been asked. In future also for your examination they will be asked. Now let us begin with the points. So see here, I have mentioned the very first point. In short I have written, but I will give you clear explanation regarding that. Very first, what exactly the meaning of geometry? What is the meaning of geometry? We have seen arrangement of electrons. They are going to be arranged in different shells of an atom. Fine. So if it is only the atom, we can clearly represent number of electrons. If it is considering s orbital, if it is considering p orbital, d orbital and so on, we can place number of electrons either in s, we can place number of electrons in p, which is dumbbell. We can also shift, or we can also place electrons in d orbital also, which is double dumbbell shape. No issue. It is very simple. But if you have two atoms combining to each other, if you have two atoms, they are combining to each other. Now, there will be a certain extent of difference we can see in their existence. But for example, note, I am your teacher. Think that I am your teacher. I am staying at my home, right? And you are saying you are staying at your home and you are visualizing the things what we are explaining here. We are far away to each other. You are there and I am here. Okay, everything is going on smoothly. If at all you are coming to college, if at all you are coming to college, surely if you are coming means I will also have to come there. So we all together will start go on discussing regarding the topics. Getting what I am telling you? So many controversies or so many discussions, and some of the things which have not been understood, all those things we will start discussing, and I'll be making a pressure on you that you have to answer. I'll make you to answer each and everything, because the things must be go deep inside your mind. That was my intention, and for that I would be doing many trials on you, right? Sometimes the brilliant students like you bear that one. You will bear and you will overcome all the difficulties in the studies, and definitely you are going to answer each and everything, and you will be feeling happy for knowledge get enlightened. Fine. So this is thing happens. Means whenever atoms come together or they come very nearer to each other, there will be a certain difference is going to happen with respect to electron cloud. What is an orbital? We have seen orbit and orbital representation. Probability of finding the electron is more in case of orbital. So those orbital of one atom and another atom, they are going to combine each other. They are going to merge each other. Fine. Then how we supposed to make them to settle? Make them to settle in the sense how they should be stayed at a particular situation. That settlement of atoms in the form of molecules is going to be explained with the help of geometry. How they should be, whether they should be V shape or whether they should be kind of trigonal shape, or they should be, whether they should be planar or and all those things are explained by, they are with a proof, they explained by VSEPR theory. First point. Next, so what I told you, Vesper theory has helped us to find out the geometry of molecules, and on which geometry they will be considered as most stable form. ಯಾವ ಸ್ಟೇಬಲ್ ಫಾರ್ಮ್ ಒಳಗೆ ಅವು ಎಕ್ಸಿಸ್ಟ್ ಆಗಿದ್ರ, ಐ ಮೀನ್ ಯಾವ ಜಾಮೆಟ್ರಿ ಒಳಗೆ ಅವು ಎಕ್ಸಿಸ್ಟ್ ಇದ್ರ ಮೋಸ್ಟ್ ಸ್ಟೇಬಲ್ ಇರ್ತಾವು. ದಟ್ ಕೈಂಡ್ ಆಫ್ ಎಕ್ಸ್ಪ್ಲನೇಷನ್ ವಾಸ್ ಗಿವನ್ ಬೈ ವೆಸ್ಪರ್ ಥಿಯರಿ. ಫೈನ್. So any molecule, next point, let us move to the next point. I have mentioned here LP, 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 BP, BP, BP. It is not blood pressure, but think here, I will be telling you the things. If you consider any atom, okay, I'll explain each and everything with an example only. Ammonia, right? So this is ammonia molecule. We all know ammonia, after binding by 3 hydrogen atom, it is going to left with 2 lone pair of electrons. Why 2 lone pair? Atomic number 7. These are said to be outer electrons. How to write? 1s2, 2s2, 2p. How many? 3. Okay. So once we done this one, it is being bonded by hydrogen. Leave these inner orbitals. They are very closely associated with the nucleus due to strong force of attraction of nucleus on the 1s2 electrons. We cannot take them for the bond participation. Fine. So for all the molecules we have to leave this. Okay. This point you have to remember. Then we have left with 2s2 and 2p3. 2p3 electrons have been given here for 3 hydrogen atoms for bonding purposes. Then we left with 2 electrons that I have shown here. Understood? Ivaga nodri. So whatever electrons I have mentioned here, these are referred as lone pair of electrons. Lone pair of electrons. Okay. Can I expand this NH3 molecule like this, NHH? Can I expand and write like this? Do you think that there are 2 electrons are involved here, right? One from the nitrogen and the other from hydrogen. Okay. So these 2 electrons which I have mentioned on the nitrogen atom are called as lone pair of electrons. Now I have another type of electrons are also present in a molecule, which are present over here, which are involved in the bond formation. They are going to be referred as bond pair electrons. What we call them? We call them as bond pair electrons. Bonding involved agavillo. There are 2 bond pair electrons with the first hydrogen, similarly here, similarly to the third hydrogen atom. So the thing is, I have mentioned here, LP is nothing but lone pair of electron and BP is nothing but bond pair of electrons. Fine. Now, I have written here in the form of increasing order. Not I, exactly it is being given by the Vesper theory. What they are telling here, this is the increasing order what I have written is with respect to repulsion. This order is with respect to repulsion. Now the question arises, what do you mean by all these things? When I have lone pair electrons, when I have lone pair electrons in any molecule, they will be showing a higher extent of repulsion. Yak helri? Electrons are negatively charged. Okay. If you consider this NH3 itself, I have lone pair of electrons present over here. Do you think these 2 are said to be bond pair electrons and these 2 are also considered as bond pair electrons, which are very neighbor to these lone pair of electrons? Okay. And these lone pair of electrons are very free. Helorilla, kelorilla. ಎಷ್ಟು ಫ್ರೀ ಆಗಿರ್ತಾವಂದ್ರೆ they do not consider the existence of these 2 at their position. What I have written here, I mean to say, ಈ 2 electron ಏನದಾವಲ್ಲ, they require higher space. ಎಲ್ಲಿ ಬೇಕಲ್ಲ ಓಡಾಡಿ ಬರ್ತೀನಿ, ನನಗೆ ಯಾರು ಕೇಳಬೇಡ್ರಿ. ನಾನು ಬೇಕಂದ್ರೆ ಇಷ್ಟೇ ಓಡಾಡ್ತೀನಿ, ಇಲ್ಲ ಇಷ್ಟು ಸ್ಪೇಸ್ ತಗೋತೀನಿ, ಇಲ್ಲ ಇಷ್ಟು ಸ್ಪೇಸ್ ತಗೋತೀನಿ. Nobody is going to question me. But the thing is, ಯಾವಾಗ ಅವು ಈ ಥರ ಬಾಂಡ್ ಟು ಸ್ಪೇಸ್ ಎಕ್ಸ್ಪಾಂಡ್ ಮಾಡ್ಲಿಕ್ಕತ್ವು ಲೈಕ್ initially like this and so on, generally this lone pair require higher space for the existence. See here. These lone pair require higher space for the existence. ಅದಕ್ಕೋಸ್ಕರ ನಾವು ಇದನ್ನ ಲೋನ್ ಪೇರ್ ಅನ್ನ ಯಾವ ರೀತಿ ತೋರಿಸ್ತೀವಿ, ಈ ತರ ಆರ್ಬಿಟಲ್ ಒಳಗ 2 electrons are existed. As these lone pair require higher energy, okay, higher will be the repulsion. ಯಾಕೆ ಹೇಳ್ರಿ, ಇಲ್ಲಿ ಕೂಡ ಎಲೆಕ್ಟ್ರಾನ್ ಇರ್ತಾವಿಲ್ಲ. These electron also negatively charged and these electrons are also negatively charged. Due to inter-electron repulsion, the bond which was initially exactly horizontal, it is going to be squeezed some to the extent of angle. Initially it was very straight, right angles to each other. All the 3 hydrogen atoms were right angles to each other. Now, due to higher repulsion of these electrons, that is lone pair of electrons, bond is going to be squeezed. It is coming nearer to each other. These hydrogen atoms are coming nearer to the next hydrogen atom. So now, what is the meaning of this one? We have lone pair repulsion. I have shown here only one lone pair. Say for example, if you consider water molecule. Let me consider water molecule now. If you consider water molecule, how many lone pair are present on the oxygen atom? Yes, there are 2 lone pairs. See, this is oxygen atom which is bonded by 2 hydrogen atoms. I have written exactly horizontal, is a straight line. Okay. Now see here, I have 2 lone pair of electrons present on oxygen atom, and one needs so much of space, other also needs so much of space. Getting 2 lone pairs. Due to present of 2 lone pairs, what will happen here? Higher repulsion is going to be seen than that of the nitrogen atom. If you consider nitrogen, the bond angle seems to be 107 degree. But when you consider water molecule, due to 2 lone pair of electrons repulsion, these 2 bonds are squeezed in such a manner that they are going to have still more little bond angle than that of ammonia. Ammonia ಒಳಗ ಒಂದ lone pair electron ಇರೋದ್ರಿಂದ they will push these electrons in such a manner that bond angle turns to be 107. But here, due to presence of 2 lone pair of electrons, they will push these hydrogen bond in such a manner that the bond angle is squeezed, or it is still reduced to 104.5 degrees. That's it. That is called as lone pair repulsion. I repeat my words. Whenever we have lone pair electrons, highest will be the repulsion. This is the example. 2 lone pairs, they will repel these hydrogen bonds in such a manner that bond angle is going to be squeezed than that of nitrogen bonding. Nitrogen and hydrogen bonding. See here. Then we have lone pair, bond pair. This is lone pair. Okay. And this is bond pair. Here also certain extent of repulsion is there, but that repulsion is not as greater as that of these 2. These 2 are lone pair. These 2 are lone pair, bond pair. Lone pair repulsion is highest than that of lone pair, bond pair. What they have written here? Lone pair will be having highest repulsion, lone pair bond pair than that of lone pair bond pair. And see, lone pair bond pair have higher repulsion than that of bond pair. ಇಲ್ಲಿ ನೋಡಿ, ಇಲ್ಲಿ ಹೈಡ್ರೋಜನ್ ಆಟಮ್ ಎಷ್ಟಿದಾವಪ್ಪ? 2 ಇದಾವೆ. So this is called as bond pair. So these 2 bond pair are coming under, these 2 electrons are coming under the influence of 2 atoms. ಯಾವ 2 atoms? ಒಂದು ಆಕ್ಸಿಜನ್ ಆಟಮ್, ಇನ್ನೊಂದು ಹೈಡ್ರೋಜನ್ ಆಟಮ್. ಆಕ್ಸಿಜನ್ ಆಟಮ್ ಈ ಎಲೆಕ್ಟ್ರಾನ್ ತನ್ನ ಕಡೆ ಜಗಾತೈತಿ, ಹೈಡ್ರೋಜನ್ ಆಟಮ್ ಈ ಎಲೆಕ್ಟ್ರಾನ್ ಅನ್ನ ತನ್ನ ಕಡೆ ಇಟ್ಕೊಂಡೈತಿ. ಹೌದಾ? ಅಂದ್ರ ಈ ಎರಡು ಎಲೆಕ್ಟ್ರಾನ್ ಅನ್ನ ಯಾವ ಗಾರ್ಡ್ ಮಾಡ್ಲಿಕ್ಕತ್ತಾವು? ಎರಡೆರಡು ಬಾಡಿ ಗಾರ್ಡ್ ಅದಾವ. ಒನ್ ಈಸ್ ಆಕ್ಸಿಜನ್ and the other one is hydrogen, because these two electrons are under the influence of oxygen as well as hydrogen. ಇಬ್ಬಿಬ್ರು ಬಾಡಿ ಗಾರ್ಡ್ ಇದ್ದಾಗ ಯಾರಾದ್ರೂ ಎಲ್ಲೆಲ್ಲ ನಂಗೆ ಬೇಕು ಅಲ್ಲಿ ಬೇಕು ಇಲ್ಲಿ ಬೇಕಂತ ಓಡಾಡಕ್ಕಾಗತ್ತಾ? ಇಲ್ಲ. ಏನಾಗ್ತೈತಿ ಈಗ? ಬಾಂಡ್ ಪೇರ್ ರಿಪಲ್ಷನ್ ಏನಾಗುತ್ತಾ? ವೆರಿ ಮಿನಿಮಮ್ ದ್ಯಾನ್ ಬಾಂಡ್ ಪೇರ್ ಲೋನ್ ಪೇರ್. ಆ್ಯಂಡ್ ಇವು ಎರಡಕ್ಕೂ ಬಾಡಿ ಗಾರ್ಡೇ ಇಲ್ಲ. ಒಬ್ಬರ ಬಾಡಿ ಗಾರ್ಡ್ ಇದ್ದಾರೆ, ಎರಡೂ ಬಿಟ್ಬಿಟ್ಟಾರೆ ಫ್ರೀಯಾಗಿ. ಈ ಬಾಂಡ್ ಒಳಗೆ ಬಿಸಿ ಆಗ್ಯಾನ. ಆಕ್ಸಿಜನ್ ಈ ಎರಡು ಬಾಂಡನ್ನು ತನ್ನ ಕಡೆ ಇಟ್ಕೊಳ್ಳೋದಕ್ಕೆ ಈಸ್ ಬಿಸಿ ವಿತ್ ದೀಸ್ ಟು. ಬಟ್ ದೀಸ್ ಟು ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಹ್ಯಾವ್ ಇನ್ಫ್ಲೂಯೆನ್ಸ್ ಆಫ್ ಓನ್ಲಿ ಒನ್ ಬಾಡಿ ಗಾರ್ಡ್. ಈ ಬಾಡಿ ಗಾರ್ಡ್ ಯಾವುದೇ ರೀತಿ ಈ ಎಲೆಕ್ಟ್ರಾನ್ ಅನ್ನ ತನ್ನ ಹೋಲ್ಡ್ ಒಳಗೆ ಇಟ್ಕೊಳಕ್ಕೆ ಹೋಗೋಂಗೆ ಇಲ್ಲ, ಬಿಕಾಸ್ ಇಟ್ ಈಸ್ ಬಾಂಡ್ ಪೇರ್ ವಿತ್ ಆಕ್ಸಿಜನ್. These two electrons are coming the influence of only one oxygen atom. Okay, so we can say that these two lone pair of electrons require higher energy. They require higher energy to exist. I mean to say higher space, more space it requires. So lone pair has highest repulsion. Lone pair bond pair has minimum repulsion to lone pair. Lastly we have bond pair. Bond pair will be having very low repulsion. That was given by Vesper theory. Do remember this point, most important. Then comes repulsion is greater when lone pair is present. The same I explained with two examples. Repulsion will be maximum. Say for example, I have methane molecule. Okay, so methane molecule olaga we have only bond pair electrons. It doesn't possesses any lone pair of electrons, so it will have least repulsion than that of ammonia. Ammonia will have least repulsion than that of water, because water has got two lone pair of electrons, ammonia has got one lone pair of electron, methane doesn't have any lone pair of electrons. So the reason why repulsion will be written in this fashion. So this is the thing what explains or what enhances the knowledge regarding the repulsion is greater when lone pair is present. So this is all about the postulates of Vesper theory, and these things have been put forth for the certain examples, and those examples confirms the postulates given are right to the larger extent. Do copy this. We'll move to next.